Alright guys, this will be a video to revise on chapter 6, which is input-output device management. We're going to talk about the theory things here. Okay, so I'm just going to fast forward and bring it towards, like those important points that we should understand about. Now, 6.1 is about device management functions. If you still remember in chapter 1, we have device manager, right? So what does this device manager do? They're going to track status, they're going to manage, they're going to allocate devices. Of course, here, 6.1, we tell you what does this device manager do. So what are their functions? Okay, and you deallocate devices, right? So there are two levels you can actually deallocate. So which are the process level or the job level. And also here we have the characteristics of input-output devices. So as you can see, we have different aspect. In each aspect, you have different variation and also example. Okay, if you look into the first thing we are actually going to talk about the access method. Okay, the aspect of access method. There are two types of way you can access. The first one, which is sequential, and the second one, which is random. Okay, so all these IO devices, I'll let you to go through on yourself. I will talk about this sequential, okay, and also the random access. Okay, first one, sequential access. If you still remember in my class, I've mentioned before, the sequential accesses act like cascade. If you don't know what cascade is, it's basically, like a few years ago, maybe 10 years ago, where we have radio. There's a button you push up, something will come down, and you have to put a sort of like a tape, okay, a tape that is in rectangle. You put inside, you close it, and then it will play it. Okay, and how does it play it, right? It's actually by rotating the tape. Okay, if you still remember or if you aware of this thing, it is called cascade. So why do I take cascade as an example? Is because for the cascade itself, it is using a sequential access storage media. Okay, the keyword is the sequential access. You can highlight in your slides when we are using sequential access, or when we referring to sequential access, it means that the records, right, are stored serially one after another. So which means when you're doing sequential access, your record is after A, then become B, then become C, then become D. So imagine you want to read the record on E, you have to rotate your tape, start from A to B to C to D, then only you can uh, get the record at position E. So each of the record in sequential access is actually identified by the position of the tape. So in order to get the record, you have to fast forward, which means you have to move the tape, okay, in order to get the record that you want. How do you get a record that you want? You have to locate the position, okay, the right position that you get the record. So this is sequential access. The keyword, I repeat, store serially one after another. Of course, you have to know that the access time of this magnetic tape, or we call sequential access, is actually varies. Okay, the maximum access is about 2.5 minutes. Average sequential. Of course, I don't encourage you to memorize the access time, just more or less to have the idea. Now, the next one. Just now, the first type is sequential access. The second type is the direct or random access storage devices. Okay, direct or random access. Compared to sequential, sequential is one after another. If we are talking about direct or random access, which means you can directly access to the record that you want, or randomly access to the record that you want. Either you want to read from that record or you want to write into that, you can directly. So the keyword is actually directly. You don't have to go one by one sequentially. You just directly go to the desired position or the desired disk area to read or write. So we have three categories here as well: magnetic disk, optical disk, or solid state memory. Okay, so the access time variance is not as wide as the magnetic tape. Okay, if we were to compare these two, sequential access and direct access, you will realize the direct access or random access is much more faster compared to sequential, because you can directly go to the desired location uh, directly lah. Okay, just that simple. So the next part, which is three factors, okay, which are three factors that contribute to the time required when we try to access a file. Okay, when we try to open a file, we know we click on the file and then open, okay, the data load out, that's it, right? But behind that, we have actually three factors that contribute to how much time is needed in order for you to access to the file. Okay, to make it simple, I normally ask my student remember this way: SST, seek, search, transfer, SST. The slowest one among these three factors is the seek time. Okay, seek time is the slowest, search time is the medium one, transfer time is the fastest. Okay, now we go into seek time. What does it mean by seek time, right? In order for you to access to the file, just hold on, guys. Let me stay in the call. All right, in order for you to access to the file, first of all, you need to check, right? Where is this file located inside the track? Which track is it, right? So the first one, seek time, we are actually referring to the time required. So we can position to the proper track. Okay, so you scan through it, which track is the one that holding your record. So that's the seek time. Now, after you have identified which track, okay, highlight, seek time is actually about locate at the proper track. After you have identified the right track, you go for search time. You are on the right track. Now, what you have to do is you need to search for the record that you wish to either read or write. Okay, that's why after seek time, you get the right track, you search for which record in the track that you actually wanted to read or write. That is what we call search time. And the last part, which is the transfer time. Once you have find the record in the right track, okay, let's say you want to read it out, so that data need to be transferred out, right? Okay, that's the time where we call transfer time, where you transfer the memory from secondary storage to your main memory. So that is seek, search, and transfer. All right. Now, the next part, in my class, I also highlighted device drivers. So what is device driver? If today you went to a Popular and get a new printer, you bring home already, you want to set up and print with wireless connection. What are you going to do? Let's say I bought a Canon printer. I'm going to go to the Canon website and then I download the Canon for my version, that printer version driver, right? The driver for my printer version. So that is what we call device drivers. Okay, it is a software program. If you ever try to install on your own, it is a software program that you install to your computer system so that your computer is able to execute. Okay, what to execute what or to operate what? Okay, basically, when you install this device driver, the software program allows your PC or your computer to actually execute or operate on the printing or the function of the device. So the device drivers, right, act as a software program to actually help your PC to communicate with the device. Okay, so here you can see interact with device component. That's what the device drivers do. Okay, now on the other hand, you have software. Of course, you need hardware in order to allow your PC to communicate with another device, right? External devices. So we need something called device controller as well. Device controller is a hardware. Okay, it is a circuit board. Over here, it's mentioned already. Device controller is a circuit board, or to make it simple, it's just a hardware that plays inside your computer so that your computer is able to connect to the OS. Okay, connect to the OS and functions in order for you to connect to the physical device like other device and also to run the device driver. Imagine today you only have the device driver software. You don't have hardware to run on the device driver. It doesn't work that way, right? So you need this device controller, which is a hardware that actually allows your PC, again, to communicate with other devices and also allow this hardware to actually work together with the software program in order for your computer to communicate to the device. So this is what happened. Okay, so for the I/O modules, for the communication among devices, you can read it on your own. I would like to clarify that don't come over to me and ask what will be coming out in your final because I have no idea what is coming out as well. Don't ask like which part is much more important. There's no weightage because we never know what kind of questions are going to come out in your final exam. So what I encourage you to do is try to get yourself understand with the theory. Okay, try to understand instead of memorizing, understand how does the things work. Okay, each and every chapter, like chapter 6 for this chapter example, what is it about and what are the things that you think you learn from it. You have to go into it. It's not just about memorizing. Okay, if you are trying to memorize, that would be hard for you because that's actually pretty lot of theory to be memorized. Okay, so that's what my opinion. But of course, if you think memorizing is your way to learn, the best way to learn, then you can go ahead. Okay, now we move on to the next part, which is 6.4.1 hardware flag. Okay, for this hardware flag, right, it's like a status. Okay, when do we use it? We use it when our device completed an operation. We need the communication, right? Okay, we can use this flag to indicate. Okay, the flag will save in this channel status word. Okay, it's a location for the main memory to, like it's this channel status word is basically a place for you to store or to hold the status of the channel. So you have to know this hardware flag, right? When the bit change from 0 to 1, which means from from free to busy. So 0 is actually free, 1 is actually busy. So when you have this hardware flag, right, you need some techniques. So here, over here, you can see the techniques, right? You need some techniques to actually test the flag or to perform this input output devices operations. Okay, the first one, which is polling. How does polling works? Okay, if you still remember in the class, is that our CPU is going to test the status from time to time. Okay, which means when you use the approach of polling to test the flag, your CPU from time to time will send out a request to test the status bit. So your CPU, like for example, every 1 second, your CPU is going to ask, got flag or not? Got flag or not? Got flag or not? Got flag or not? So every single second, they do polling. So that's what polling call. Now, this way, there's a very, very big disadvantage, okay? Which means it have a big cons, which is how often should we ask the CPU to go and poll? How often should our CPU to test the bit, the status bit lah, which is the flag. Okay, if you do it too frequently, like you do it every single second, your CPU is wasted to test the flag because you do it every single second. It doesn't mean every single second you're gonna have flag change, right? So if you do it too often, you're gonna waste the resources. But if you say, okay, I don't want to do it every single second because it is not efficient, let me do it every 30 minutes. If you do it every 30 minutes, which is you done too seldom, right? There could be chances of happen where, because you do it every 30 seconds, maybe in this 30 seconds, maybe in just the third second out of this 30 seconds, right? The third second in out of this 30 minutes, okay, that's actually flag, but you didn't poll it, so you don't know it happens. Okay, so for whatever I'm explaining over here is actually these two sentences. The only disadvantage for polling is you're gonna waste your resource, and I would say polling as a technique is not smart enough. All right, now let's move on to the next one, which is the interrupt. Okay, when we talk about interrupt, we are going to use interrupt to test the flag. Okay, so how do you actually test? So it's like your CPU focus on whatever it is running, unless there is an interrupt. Okay, now where there's interrupt, then we transfer the control to the interrupt handler to go and handle this flag. Okay, so this is what happened when we try to use interrupt. That's much more smarter. And the last one, which is DMA. Okay, this is the best way we say. Okay, because it is called direct memory access, right? When we talk about direct memory access, it is a technique that it doesn't need your CPU to do the work. Okay, it doesn't need your CPU to do the work. Instead, you let the CPU, right, pass the information to control unit, so the control unit can do the work directly. Okay, so you can look into it. The best, I mean, you can start here or you can read everything also. So the best way for me to explain to you is that when you are using DMA, right, what happened is CPU send information to control unit. to initiate transfer. Basically, your CPU send data to the control unit, and what happened? Your CPU can continue on its process. It doesn't have to pay attention into check on this access main memory, check on this transfer, check on this flag, things like that. Because once CPU send the info to control unit, the control unit is going to handle everything in itself. Okay, so in that case, your CPU is free to go for other tasks instead of sitting there to do the polling or to do the interrupt handler. So this is what direct memory access mean. Okay, until this part, okay, we go to 6.4.3, which is buffer. Now, buffer is pretty easy. To remember, buffer is temporary storage. Okay, buffer, temporary storage. Now, if you want to know more, of course, you can know like the temporary storage, it will resides in convenient location. Sorry, excuse me. It resides in convenient locations such as your main memory, channels, and control unit. But to make it short, buffers are actually temporary storage. Okay, and over here we have this double buffering. Okay, if to compare, you have one buffer and two buffer, which one is much more convenient or which one is much more efficient? The answer will be two buffer. Why? Because look at this example. When you have two buffer, when buffer one is being read by CPU, right? Your buffer two is not using, so you can write whatsoever into the buffer. And once your CPU done reading for buffer one, now buffer one is empty already, right? And buffer two is filled with the data from the disk. Now your CPU can directly read from buffer two, don't have to wait, and then you can continue to write data from this into buffer one. And then after buffer two is done, then your CPU continue to write buffer one, then you continue to reload the data from this into buffer two. So this is what happened. When you have two buffer, then you can work simultaneously to pass in the data and load the data, and your CPU can consume directly from the buffer without having a long waiting time. So this is the about double buffering. Okay, now for management of I/O requests, I would suggest you go to look into it, read it on your own, because it's just telling you that, okay, we have actually three components and what does all these components do lah. Okay, with that being said, okay, this is something you might need to know as well. When the process or when a process, we require input output, okay, or from something like we need something from the disk, it will issue to call the OS and request for information. So like whenever you need input output and something, right, you will need some information in order to proceed lah. Okay, so it's like, for example, is it you want to do input or output, and where are the disk address, where do you want to go, and what about the memory address, where should the system or your computer system go to find it, and also the size of the file. All right. So with that being said, right, the strategies here, okay, I won't talk about this calculation in this video because this is aimed for theory only. You can go over to my other calculation video recording. In that, I will teach you how do you draw the first come first serve, shutter seek time first, scan, and also the look scheduling. Okay, so with that being said, oh yeah, the algorithm, they have advantage and disadvantage as well. So you have to study this thing. Imagine now your final come with the questions, compare and contrast the algorithm for FCFS and SSTF. Then you have to tell, hey, compare, what are these, what are the difference? Okay, apart from you say, oh, first come first serve depends on if the driver, like it came earlier, then we go and serve it, right? Yeah, that is right. What else? What are the advantage? What are the disadvantage? You have to know as well. So it's like FCFS, the most easiest way, easiest logic to implement. Okay, but there's a disadvantage lah. When it is easy to implement, because you just go with the flow, right? You go with the order. So it actually doesn't provide us the best average service. Okay, so this is an example that you have to know lah. So this question, you can try it yourself at a past year. I shall end the video until here.